Hello students, welcome to Punj classes. Now we will discuss transfer of heat. Transfer of heat. There are three ways in which heat is transferred from one place to another. First one is conduction, second one is convection, and third is radiation. Now we will discuss first method, conduction. Conduction, it is the process by which heat is transferred from one point to another through a substance in the direction of fall of temperature. Without the actual motion of the particle of the substance through which heat can pass easily are called good conductor of heat. Silver is the best conductor of heat, and the substance which does not allow the heat to pass through them and are called bad conductor of heat. For example, wood, glass, air, etc. So this is called conduction. Now coefficient of thermal conductivity. Consider a slab of thickness D and area of two opposite faces is equal to capital A, as in the diagram. Distance between the two faces is small d and area of each face is capital A. If temperature of one face is T1 and of other face is T2, where T1 is greater than T2, that is, the face in the left hand side is hotter than the face in the right hand side, then amount of heat flow capital Q from hot face to cold face is number 1 directly proportional to the area of the face. Mathematically, Q is directly proportional to A, and let it be equation number 1. Number 2, directly proportional to difference in temperature of the two faces. Mathematically, Q proportional to T1 minus T2, and let it be equation number 2. Number 3, directly proportional to time small t. Mathematically, Q proportional to T, and let it be equation number 3. Fourth one, inversely proportional to the distance between the faces. Mathematically, Q proportional to 1 upon D. Let it be equation number 4. And fifth point, depends upon the nature of the material. Now, combining the above equations, we get Q proportional to A into T1 minus T2 within the bracket into small t upon D. Now to remove proportionality sign, we will use a constant of proportionality, or Q is equal to Ka into T1 minus T2 into small t upon D. Let it be equation number 5, where capital K is constant of proportionality and is called coefficient of thermal conductivity. If A is equal to 1 unit, D is equal to 1 unit, difference in temperature of the two phase T1 minus T2 is equal to 1 degree C and T small time is equal to 1 second, small t is equal to time is equal to 1 second. Then from equation 5, Q is equal to K into 1 into 1 into 1 upon 1, or K is equal to, Q is equal to K. This implies K is equal to Q. Q is the amount of heat transferred from hot phase to cold phase. Therefore, the coefficient of thermal conductivity is equal to the amount of heat flow per second across the opposite faces of the cube of unit length if the faces are kept at temperature difference of 1 degree C. This is the definition of coefficient of thermal conductivity. So thank you very much.